Hello, this is another geometric sequence, or what we call a GP, geometric progression. Remember, the standard formula for calculating the nth term is AR to the power of n minus 1. This is the one that you must just simply know. Okay, now if we look at this example, they're telling you that the fourth term is 2/3. So term 4 people is 2/3. And then they say the sixth term is 3/2. So this is equal to T6. You must find A and R. So you must find the first term and you must find the common ratio. Right, now as I have taught you in the previous videos, the first step you do, you identify the information given or the information asked. Right, now in this case, TN people, we've got two possible TNs. We got T4, which is 2/3, and we've got T6, which is 3/2, right? So immediately, people, we will work with two of these formulas because we've got 2/4, so we've got that once, and we've got 2T6, so we've got another one of those. So we will work with two formulas at the same time. All right, now if we look at A is being asked, so that's a question mark. Then the ratio is asked, so that's a question mark. Now, under arithmetic progressions, where we had two variables, our mind goes to simultaneous equations, which in this case is also true because we're going to have two variables. Okay, and then n, we must now, for T4 people, n equals 4. But for T6, n equals 6. So again, people, that will refer us to two different equations. So what we will be doing, as in all the others, we will start by writing the standard formula. Now for T4, we can now substitute Tn being at 2/3. A we must calculate, R we must calculate, and n has become 4 minus 1. So we can simplify the right-hand side, which gives me AR to the power of 3. So that's my one equation. Now I will work with my second equation. So again, we will start with our standard formula. We will now substitute T6, so Tn, with 3/2. A will remain A because we must calculate that. R will remain R because we must calculate that. But now n is 6, so we have 6 minus 1. And if we simplify that, then we get AR to the power of 5. So this gives me equation 2. Okay, now very importantly, we cannot use the elimination or substitution method for finding A as well as R. In this case, and that's now a new concept, okay? It's a new concept. We are going to divide equation 2 by equation 1. And you will see just now when we do that, we will also eliminate one of the variables. So, I repeat, this is a new concept in solving equations where we have two variables. This we apply to only geometric sequences, okay? We are going to divide the two equations. So let's take equation 2. This is 3/2, okay, which equals AR to the power of 5. We then going to divide, okay? So this equal sign comes to the middle. And we are going to divide by equation 1. So equation 1 reads 2/3 equals a r to the power of 3. Okay, now when you put this into your calculator, 3/2 divided by 2/3, then the calculator is going to give you 9/4. Right. When you now look at the right-hand side, people, we've got a divided by a, so a cancels, which means a is eliminated. Okay, so it is basically a method of elimination. But then we still have r to the power of 5 divided by r to the power of 3. So when we divide powers with the same base, we subtract the index, isn't it? So that gives me r squared. Okay, now we still want to find r. Okay, the value of r, which means we must get rid of this squared. We will use Goro is o, and the opposite operation of squared is a square root. So we will take the square root on the left, okay, and if we put that into the calculator, remember the square root is always a plus or minus. It will give you an answer of 3/2. And we have moved that to, so on the right hand side, we've got r left over. So when we go back to this, we already calculated the r. The value of r is 3/2, which means we must now still find a. Now that we will do in the same way as we did for simultaneous equations. We are just going to take one of our equations and we are now going to substitute our answer for r into that equation. So I'm going to use equation 1, which reads 2/3 equals ar cubed. Okay. Now I will substitute the value of 3/2 into the place of r. So this becomes 2/3 equals a. Now instead of r, I'm going to write 3/2, and don't forget this needs to be cubed. Okay, so now I'm going to calculate the right hand side, which gives me a times 27/8. Okay, which is 2/3. And now once again, I've got a linear equation with one unknown. I want to find the value for a. So I'm going to use the golden rule, which is the opposite operation. So on that side, that becomes divide by 27/8. Okay, and if I calculate 2/3 divide by 27/8, then that answer will give me 16/81. Okay, and on the right hand side, I will have got a left over. This I have moved. So my answer to a is 16/81. So let's go up here again. A was a question mark. This is 16/81. So we have solved the equation. All right, I repeat, because they are giving you two terms, they give you term 4 and term 6. We basically have the information of T4 and T6. That is slightly differently. That should then bring our mind to two different equations. Okay, so we've got T4 and we've got T8. A and R is being asked. Okay, so in both cases, A and R is being asked. Then in the position, it is giving you the 4th position for 2/3, and it's giving you the 6th position for 3/2. Right, then what you do, you're working with two equations because you've got the information for two different terms. Okay, working with two equations, we substitute value and we simplify. That we do with the same. You substitute value and you simplify. Then comes the new concept where we solve these two equations simultaneously by dividing them. Okay? And we divide equation 2 by equation 1. Simply, people, because r to the power of 5 is more than r to the power of 3. Okay, that's why I divide the equation 2 by equation 1. All right, then if you have done that division, you basically simplify, you then do Goro's okay, and you solve for A. So now A has given you an answer of 1681. Remember, you can always do your check, right? You take the original equation, take the first one or the second one, it doesn't matter, AR to the power of 3, then you substitute the value of A, which is 3 halves. You then substitute the value, A is 1681. You then substitute the value of R, which is 3 halves to the power of 3. Put that into your calculator, and that will give you an answer of 2/3. So the left-hand side equals the right-hand side. And with that, we know that my answer to R and my answer to A is correct.